Today we're going to talk about how to factor a difference of squares. When you factor a difference of squares, you'll notice that you have to have a difference, so you have to have a minus sign. But also you need to think of what the coefficient and constants are perfect squares of. And then it will always be in this format of a squared minus b squared. So in factored form, that equates to a minus b and a plus b. The reason you have a plus and a minus is because you want to get rid of that middle term. And like you saw in the trinomial video on number 8, that m squared minus 49, that factored into m minus 7 and m plus 7, that's what made the b, that linear term, disappear. So that's what we're going to do in this video. So in our first example, we have x squared minus 9. So we know that a squared is x squared. So if the squared term is x squared, then a regular a is just going to be x. I know b squared is 9, so the square root of that would be 3, so regular b is 3. From here, I just have to put it in my format, a minus b and a plus b. I know a is x, minus b is 3, and then x plus 3. And again, if I double check, x times x is x squared, x times 3 is 3x, and then minus 3 times x, and then negative 3 times 3 is a negative 9. So right here you'll see that this b term disappears, and that's how I end up with x squared minus 9. That checks out. We'll do another one, number 4 here. We have 4x squared minus 225. So in this one, again, we want to see what our coefficient and constants are perfect squares of. Well, I know 4 is a perfect square of something, so I know a squared is equal to 4x squared. So regular a, well, the square root of 4 is 2, and then the square root of x squared is x. And then if you think about it, 2x, that whole thing squared, is going to give you 4x squared. So once you think you have your a, you can always double check by squaring it to make sure that you end up with what you started with. So a is 2x. We know b squared is 225. Well, the square root of that is 15, so b must equal 15. And again, we just put it in the form of a minus b and a plus b. So I'll have 2x minus 15 and 2x plus 15. If you look at number 6, we have 50x squared y squared minus 8y to the 4th. In this example, you'll notice that the 50 and the 8 are not perfect squares of something. But you could divide it by something to become a perfect square. So if I took out a 2, 50 divided by 2 is 25, x squared y squared. And then this 8 divided by 2 gives me 4, y to the 4th. Now I have perfect squares and I can go from there. So a squared is 25x squared y squared. So regular a is going to be 5xy, because the square root of 25 is 5. X squared, if that's not squared, is going to be x. And then y squared, if you square root that, you get y. So a is 5xy. We have b as 4y to the 4th. Well, let's say b squared. That means b is going to be 2y squared. Because if I were to work backwards and take this b and square the whole thing, that's going to give me 4y to the 4th. So this is b. And again, we just write it in our form. So I have 5xy minus 2y squared and 5xy plus 2y squared. So I want you guys to try the other 3 problems now.